Hello everyone, I hope that this video finds you well and that you and your family and loved ones are all healthy. Today I just want to go over a few key points on validity and reliability. So I want to start today by going over what are the requirements for assessment validity and what can threaten the validity of the measurements of your students' achievement. So just as a quick definition, validity is how well a test is measuring what it's supposed to measure and the quality of that measurement of the underlying construct. So for example, I'm a statistics teacher. So the construct of interest for my course would be how well students understand some theory in statistics. We'll just say it's a theory of probability, okay? As I create a test, I need to make sure that my test will actually measure their understanding of some theory of probability. How well my test is able to measure that understanding is my test's validity. In order for validity to exist, there are 5 conditions that need to be met, and they all start with the letter C. That's how we kind of remember them. The first one is consistency. Another way to say consistency is reliability. So basically, can the results be reproduced? The next one is construct validity. Are the constructs aligned with the content? The next one is the content validity. Is the content aligned with the domain? The next one is the criterion relatedness. Are the behaviors aligned with the construct? Consequential validity. Are there other consequential aspects to the assessment that need to be taken into account? Let's unpack these a little bit more thoroughly. The first condition is the condition of reliability, or as I said, another way to say that is the condition of consistency. In order for validity to exist, you have to have reliability. Without reliability, there is no validity. So what we say is that reliability is a necessary, but it's not sufficient condition for validity. Let's look at an example using just a dartboard on what it means for something to have reliability, but not validity, and validity with reliability. So when you look at a dartboard, you're trying to measure how well someone can aim, right? How well somebody can hit the bullseye of a dartboard. So here in this one right here, and I'm going to go ahead and use my little pointer. In this example right here, whoever is throwing these darts, right, they're hitting the bullseye exactly where you're supposed to hit it, in the center. Not only are they hitting it in the center where they're supposed to hit it in order to measure ability to aim, I guess, they're able to hit that bullseye over and over and over again. In this case, we have validity and reliability. Validity because it's hitting the mark exactly where it should, and reliability because it's able to hit that mark over and over again. If we were to go to this other side right here, this person that's throwing the dart was not able to hit the bullseye. Right? So they're not hitting it where it's supposed to hit, but they're hitting it over and over again in the same section. Here they have reliability because they're able to reproduce the results over and over again, but they have no validity because they weren't able to hit the target exactly where it was supposed to hit. Where you have no validity or reliability is in this instance right here, where this person hit the bullseye once, and then they hit it all over the place, right? They didn't hit the same section over and over again. Since the results were not reproduced, they do not have reliability. And since they did not hit the bullseye, which is where they were supposed to hit, they don't have validity either. When we're looking at reliability, we're looking for a way to be able to reproduce the results in order to have reliability, and look to see if there is some level of convergence among multiple sources of evidence. There's different ways you can check for validity. Just like item selection, it depends a lot of the times on what you teach. If you were to teach something where you're able to use maybe selection type items, so multiple choice, true, false, and things like that, because the questions or the items are sort of geared to go a little bit faster. Students can complete more of those selection items within a certain testing period. You might have more of a chance to get a larger sample to test for validity. However, if you are an English teacher, right, you can't give several essays within a testing period. It's really difficult to do. A student might be able to complete 1, maybe 2 essays in an hour if they're lucky. That doesn't give you as much of a sample size in order to test reliability. You look to see, do you have some information within all the different types of scoring or the types of assignments that you've done in order to see if there's some way to sort of match things up, looking for validity and reliability. If you're looking to make decisions with some kind of like lower stake type things, you can maybe deal with a smaller sample size in trying to identify areas where there has been some validity. But if you're looking for high stakes decisions, things like whether a student will be placed in some sort of special course, whether they'll be given some sort of special service, perhaps grading, pass-fail type of decisions, then you want to at least look for multiple measures. You're looking for more reliability in those situations. There's lots of reasons why scores can be inconsistent. It can be just sources of random error, day-to-day fluctuations. Sometimes somebody has a bad day, so their scores aren't going to be as reliable. It could be the types of forms that you're using. Maybe one day you're doing a multiple choice type of form, and the other day you're doing an essay type of test. And so that type of item is affecting the tester's reliability, ability to perform in the same way. It can also be rater fluctuations. One day you might be a little bit more aligned with the rubric than another day. So you're not dealing with any sort of rater drift or anything that might affect the rating. There's lots of reasons why things can be inconsistent, but there shouldn't be a huge fluctuation. So let's talk about ways where we can have some indication that we have reliability. Now, I don't want you to get freaked out or anything. I know some of you have already mentioned to me that you have a little bit of a math phobia, but I promise I'll walk you through this and it's not that big a deal. So we can use this calculation called a correlation coefficient in order to look at the strength of a relationship between two scores. Okay, so before we go into a couple examples, and I'm going to show you some shortcuts in order to get this, I want to just do a quick little review of lines. I'm going to go ahead and just do a quick review of lines. Here is a line, okay? It's increasing. This this black line is increasing. And we're going to say that this is a positive line. It's increasing. And in this case, I'm just going to go ahead and give it the value of positive 1. Okay? So this is a perfect positive 1 line. In red, I'm going to go ahead and make another line that goes this way. And in this situation, I'm going to say that this line is showing that something is decreasing. And where this one was a perfect positive 1 line, this is a perfect negative 1 line. If we look what is exactly in between the two lines, right, we can say that the number that is exactly in between positive 1 and negative 1 is 0. Okay? Now, between 0 and positive 1, I have an infinite amount of numbers, right? Exactly in the center, I could say that this is, I'll do that one in black. I can say that exactly in the center here might be positive 0.5. And maybe exactly in the middle here of 0 and negative 1 would be negative 0.5. Ultimately, this positive number right here, right, this positive is saying that something is increasing or that there's a positive correlation. In exactly the opposite way, I can say that anything that's between 0 and -1 is a negative correlation. If I were to look at a scatter plot, for example, and I'm going to go ahead and make my dots here in black, right? And let's just say I have dots that are kind of looking like this. I've got a line that's kind of looking like this. The closer that my line would be to +1 means that I have something that's a very strong positive correlation. If I had something that was down here, I would still have a positive correlation, but I would have a weak positive correlation. The same thing can happen between something that's between 0 and -1. If I have, let's just say I have a scatter plot and its trend line was very close to 0, right? Then it would be a weak negative correlation. And if I had maybe a scatter plot that was very close to -1, I would have a very strong negative correlation. Okay? If we were going to kind of look at this in terms of, I'm going to scooch this down a little bit here. If I were going to basically look at this in terms of strong and weak and moderate, and I'm going to go ahead and draw my lines here again. Do black. This is 0. This is +1. This is -1. The closer a line is to +1, or the closer the trend line would be to +1, the stronger it is. If it's here, closer to 0, then it would be a weak. But as long as it's still inclining in a positive direction, it's still positive. So this would be strong positive, weak positive. It's right. If it's right in the center, you would say that there's no correlation. If something is tilted downwards, it's still negative, but it's weak. And if something is very close to -1, then it's strong. You could call this center area maybe moderate. There is no rule of thumb when you're talking about correlations. It's very much sort of like a loose, very fluid type of description. So let's go back to the slide here and look to see what does it mean when you have a correlation in terms of test scores. We already kind of discussed this very, very loosely. The sign in front of a number is going to tell you if you have an upward slope, an increasing slope, in which case it's positive, or if you have a downward decreasing relationship, which is negative. The closer you are to +1, then you have something that's very strong, but it's positive. The closer you are to -1, you have something very strong, but it's negative. And the closer you are to 0, you are looking to a very weak relationship. Now that we've kind of talked a little bit about how to interpret what this means, let's look at an example. If we're looking for reliability, there's different ways you can find reliability. One way is by using parallel or alternate forms. Say I'm going to give a test on calculating mean, median, mode. And I have two versions of that test. I have test A and test B. They have more or less the same type of questions, right? Maybe there's 4 questions on mean, 4 questions on median, 4 questions on mode, and the same is happening in test B. That's called a parallel form, okay? I could give my students test A, say on Monday, and test B, say on Tuesday, and if there is reliability, there should be a pretty strong correlation between the two. Another way to check reliability is the test-retest, where the students would take a test and then time would go by and they would take another test again. A lot of times we would see this in elementary school where teachers were constantly testing the multiplication facts, where they would just test and retest and test and retest. You would see some fluctuation in day to day, but ultimately, if a student did really, really well on Tuesday, they're probably going to do really well on Wednesday. You're not going to see too much of a fluctuation. You would have a pretty strong idea of how reliable your tests are. If a student's scoring 80%, 80%, 81%, 82%, every day you're starting to see this trend coming out, you're starting to see reliability. Here is how we're bringing it all together. So here is a situation where a researcher administered a psychological test to 44 students, and they decided to measure several types of traits like tension, depression, vigor, etc. So the first time they gave this was time 1, and they had a variety of scores. It says they have 44 students, but where it says ... I guess those were the missing students, right? And then some time went by, and they looked to see what were their scores the second time. And you started to see their scores here. If you plotted it with test here on the x-axis, so the first time they took the test and the second time they took the test, you would see that there is a trend, upward trend, so a positive trend. 0.77 is your correlation coefficient. First of all, it's positive, so there's a positive trend happening here. So here's the 0.77, positive trend. 0.77 is pretty strong, right? It's pretty close to 1. It's a moderately strong correlation. So what they were able to do is that this showed that there was consistency over time. People that scored high the first time scored high the second time. People that scored low the first time scored low the second time. There wasn't too much change over time. The thing about retest and test, alternate tests and all that kind of stuff is you need 2 testing iterations to do that. And if you're teaching 180 days a year, let's just say that you have 10 chapters that you're supposed to cover in a year's time. In 180 days, you've got to make sure that you split the time up so that you can give those 10 exams. So now you're down to 170 days. And you're going to have all kinds of days that are kind of messed up for you because of fire drills and assemblies and other types of tests and field trips and things like that. If you were to give 10 of those days to just regular tests and then another 10 of those days to retesting or parallel forms, that's a lot of testing days. That's a lot of days that you're not able to instruct. So another way that you can look for reliability is this thing called a split half, where what you do is you put 2 items on the test that are related. So the kids are taking one test, but the 2 items are related. So half of the items test 10 principles or theories, and then there's a matching question on the other half of the test that does the same thing, and then you align the questions. Here is what's happened. They've taken half of the test and the questions that were aligned, and the other half of the test and the questions that were aligned, and they came up with a correlation coefficient of 0.80. Again, this is a positive correlation. So students that scored well on the first half of the test scored well on the second half of the test, and students that did not score well on the first half of the test did not score well on the second half of the test. This is a positive correlation. It's pretty strong. It's very strong, 0.8. And it's showing that there is good to moderate consistency over the content. This is some evidence of validity. This is not enough evidence for a test to be valid, but this is starting to look good. You've at least hit the reliability condition that's so important. So the next type of validity we're going to talk about is construct validity. So for construct validity, you want to know if the constructs are aligned with the content. As a reminder, constructs are hypothetical attributes that exist in the mind. It's not something that we can actually see. All we can do in order to measure them is to create tests filled with items that are likely to elicit behaviors that are associated with that construct. Because we can measure behavior, we can see behavior, and we need something that is going to be the impetus of that behavior. A couple things that might threaten construct validity are if the construct is underrepresented in the exam, in the measurement device, or if there is anything that is irrelevant to the construct within the test. When we're looking at construct validity, two things can happen. We can have convergent validity, in which the scores of the test you created to measure the construct is more highly correlated with another known test that does measure that construct. And we can have divergent validity, where the scores on your exam, on your instrument, are less correlated with tests or instruments that are designed to measure other constructs. So let's look at an example. There's a lot of constructs and content and C words in here. Okay, so as a mathematics teacher, you might develop an end of semester algebra test for the class. And the test should cover every form of algebra that was taught in the class. If some types of the algebra are left out, then the results may not be an accurate indication of the student's understanding of the subject of algebra. So that would be an underrepresentation. Also, if the teacher includes questions that are not really related to algebra, like maybe it has something to do with statistics, or maybe it has something to do with geometry, then the results are no longer a valid measure of algebraic knowledge. In terms of looking for convergent and divergent validity, a math test should be more highly correlated, right? Looking at the correlation coefficient, should be more highly correlated from scores with another math test than with scores from a reading test. Okay, there should be a greater correlation between two math tests than a math and a reading test, which seems perfectly logical, but so many things are. The next type of validity is the content validity. Is the content aligned with the domain of interest? Very similarly to our construct validity, content validity looks at a couple of the same type of things. Number one, is there a match between the items on your exam or on your instrument and the objectives or standards that you are planning to assess? And are the behaviors aligned? Are the students engaging in behaviors that you would normally see with anybody working with that type of content? Also, is there enough of a sample so that you can actually measure the grade level achievement? So how do we obtain content validity? It's really just looking at the behaviors aligned with the construct. They rely on expert judgment. And for our case, the expert judgment would be the creators of the standards. So if something is written within the standards, that's enough to obtain content validity. So let's look at a content validity in terms of just like a pre-employment test. So it says, one way to validate a pre-employment test is to measure how well a test is measuring a quality or a skill that is related to a certain job. In other words, is the test's content effectively and comprehensively measuring the abilities required to successfully perform the job? If the Equal Employment and Opportunity Commission looks at this and says, yes, this test is actually aligned with this type of job, or saying, no, this test is not aligned with this type of job, that would be one way to validate the test's proper use for the hiring process. So let's say that they make you take a typing test, but there's not a lot of typing for that particular job. Then if the Equal Employment Opportunity Commission came in and said, according to this job description, this test does not really measure how well someone could possibly do at this type of job, then that's enough to say that the test does not have content validity. The next one is the criterion relatedness. So are the elicited behaviors aligned with the construct? Criterion related validity, for us, a lot of times it's the prediction. How well can this test predict an outcome? You see this a lot with high school grades. High school grades are the greatest predictor for college achievement, as well as SAT, which is also a predictor of the student's first year in college. They're meant to predict. You can have postdictive or concurrent criterion validity, but more as teachers, we really look at predictive. So here we looked at a predictive validity. Here are students' placement tests for a chem course and their end of the semester course grade. Here we can see that there is a positive correlation. We don't really know what the correlation coefficient would be, but it's a positive correlation saying that students that did well on the placement tests also received a high course grade. So here we have some sort of predictive validity. We're seeing this trend happen over and over again. If we looked at this, here is the same kind of things. They looked at, and this is actually true data, where they did a study based on 667 first-year chemistry majors, and they looked at their score on the first exam, and they looked at their final course grade to see what the correlation was. And they found that there was a correlation coefficient of positive 0.74. So it's a very strong correlation that students that did well on the first exam went on to do well on the course as a whole, and students that did not do well on the first exam went on to do poorly in the course as a whole. So what they could do for something like this, and what I could see happening in your school, is when you got into groups to kind of look at data for your school, is thinking where would be a good cutoff to maybe give these types of students either some additional course support, to put them in some preparatory course before going into it, looking at the skills that these students may be lacking, and being able to help these students actually achieve. So here it is just again in a larger so that you can see it. You see that there's a definite trend here. Students that did well on the first exam went on to do well in the course. Students that did not went on to do poorly in the course. One thing that I should kind of bring up is that when you're looking at the correlation coefficient and you have outliers, these outliers can greatly affect the correlation coefficient. So you have to be really careful that when you're looking at a scatter plot, if you are looking at outliers, you might want to see what the effect of that outlier is. So here we have a sample of 20 people, and this is the correlation coefficient. This person right here has this score, and with this person right here, their correlation coefficient was 0.64. When we took that one person, right, that one score, and it became an outlier down here, the correlation coefficient dropped all the way to 0.05. So here where it had a moderate correlation, here it had a very, very, very weak correlation. So if you have outliers, you're looking to make decisions about students based on correlation coefficients, it's always good to kind of take a look at the visual representation of the data to see if there's anything like an outlier, to see maybe what is the effect of that outlier. So especially in small samples, when you have a small sample, you're going to get more of a change in the correlation coefficient. The last type of validity is really sort of a controversial type of validity condition, and it's called the consequential validity. And are there other consequential aspects to the assessment that should be taken into the account before being used? There are times tests that were supposed to measure one thing, one particular thing, we'll just say it's math achievement, are used in order to make decisions for other components. Like, for example, if I took a Regents test that was meant to measure my ability to do mathematics, that test is supposed to be used to measure how well I can do mathematics. It's not supposed to measure how successful I will be if I'm put into a college prep track, or how successful I would be if I'm put into an AP course instead of a general course. So when you start to use tests that were not designed for a specific purpose, then you should look at the consequences that can occur. Tests are made for an intended purpose, and don't muddle those scores by using them for other unintended purposes. One of the examples that comes to mind is the No Child Left Behind, LCLB, or some of them called them Nickelby, testing, and where the testing was supposed to look at how well students scored or understood material for their age group, but the negative unintended consequences were that many schools had their funding taken away. That test is not supposed to be used in order for the schools to be measured in effectiveness. That's not what that test is supposed to be measuring. It's only supposed to measure how well the students happened to perform on that test on the particular day the test was given. Also, negative consequences were particularly high for special populations. So areas that had a lot of transiency. The students were coming in and out. There was a lot of changes within the schools, populations where there were a lot of special needs students, populations where there might be poor nutrition, etc. Those were negative consequences that resulted from the No Child Left Behind testing. That really was not the purpose of the test. The purpose of the test was to see how well students performed on standards. So here's an example for consequential validity. Your school has decided to create an honors college track program. In order to select students for the program, you have decided to use the results of a school-created standards content-based math placement exam and the math portion of the PSAT. And you decide to make the following grid for decision-making purposes. All right, on this side we have the PSAT. And on this side we have the math placement test that the teachers at the school decided to create. If a student scores below 50 on the PSAT and below 80 on the math placement test, they are not going to be placed in the track. If the student scores above 50 on the PSAT and above 80 on the math placement test, then they're definitely going to let them into the college track program. However, what would happen if a student scored really well on the math placement exam that the teachers created, but they didn't score well on the PSAT? They scored below 50 on the PSAT. What happens then? And what happens if a student does really well on the PSAT, but does not do very well on the math placement test? So they're in this area. In this situation, you're using two different tests. The PSAT is looking to measure how well the students are being prepared for college, and the math placement exam is looking to see how well the students did according to the creators of the exam, right? Whatever they did to create the exam. So you've got two different kinds of students. You've got that might fall into these dark gray categories. You could accidentally put them into the higher tracked course, in which case if they're ready for the course, they'll do fine. If they're not ready for the course, then they could be pulled out and then put into a regular math course in which they've missed part of the semester already to put them at a disadvantage. Or if we don't put them into that AP test and they should have been put in, then they're missing out on an opportunity. So with these kind of things, you want to be really, really careful when you're making decisions based on test scores, like what are the consequences and how will they affect students? A lot of the times, and this is one of the arguments against the specialized high school testing, is that it's not identifying students that have not had extra tutoring, have suffered from malnutrition, do not have a quiet place to study, etc., from entering the specialized high schools, although there might be another exam that might show perhaps their aptitude for the specialized high school type of curriculum. This is the same kind of thing. If you incorrectly accept students into the program, the students are accepted in the program, but the issues are that, number one, they might fall behind, they might feel bad, they will have to go back into the old class, they'll waste time. Incorrectly, the students are not having access to a program that they would have maybe thrived in. Let's look to see if we can put this all together. Okay, so it says, a group of colleagues are preparing a 50-item math aptitude test to be used to place incoming 9th grade students in either regular, honors, or remedial math classes. What kinds of evidence about the technical qualities of the assessment might be most important to gather? All right, so let's think about this. Consistency. You absolutely need consistency because without consistency, you have no validation. If you were looking at this test, how consistent are the results of these tests going to be when you're looking at maybe past behaviors, or if you were looking at a test-retest type of situation, or if you were looking at parallel items on the test and doing like split half reliability. As far as content, we could do content and construct at the same time. For content, are the items on that test align with the standards that your school uses, whether they use the Common Core State standards or some other type of standards? Is it related to expert review? Is there peer-reviewed journal evidence for these kind of things? Or as far as content, is the content represented on there? Is there enough within those 50 items to be able to make a determination that the skills that are going to be necessary for students to be successful in either regular honors or remedial math classes are represented within that test. And also, is there anything that is on the test that may not be related? Okay, is there anything that might be related to some other type of branch of mathematics, geometry, something like that? Like, so you're going to check those. For criterion relatedness, is there any evidence that exists that the prediction that you're making or the decision that you're making in the placement of these students has worked in the past? Has this test been tried before? What were the results? Okay, so maybe before actually putting this type of selection process in gear, maybe you want to sort of like anecdotally give the test, but not necessarily make the decision on where to place them, and then look to see how the students fared at the end of the year relative to their scores at the test. Are you looking at a positive correlation? Finally, are there any unintended consequences because of this? What happens if you're not able to place the student correctly? What are the consequences to that? So really kind of keeping an eye on all of these for this particular situation, for this particular scenario, I would argue that all of these are very important. Consistency you have to have no matter what. The construct, again, what kind of behaviors are being elicited? Are those aligned with construct? The content, are experts in agreement that this type of content is aligned with the construct? Since this is going to be used for a predictive nature, do you have any past data that would reinforce your belief that this type of test is going to give you valid results at the end? And how are you going to deal with the unintended consequences, if any? Here's another one. It says a colleague is preparing a group project, research, and presentation to use as one of the several summative assessments in 9th grade Earth Science. What kinds of evidence about technical qualities of the assessment might be most important to gather? Number 1, consistency. You need consistency for the members in the group. Group projects, you don't know who's doing all the work, if it's being divided equally. How much does each group member understand? What level of reliability are you looking for each one of the group members? Also, is there enough representation of the material that you're looking to measure within the group project? And how is everyone being held accountable for it? Are there any biases that you also need to address? Are the behaviors being elicited something that are aligned with the standards? So as far as content validity, are what's in the standards, which are basically created by experts in the field, are the standards aligned with this assignment? It doesn't look like this is really looking to predict anything, so I don't know that criteria relatedness is necessary. Consequential validity, I mean, the consequence of the summative grade is some, but it's pretty kind of low stakes. If it's just one piece of the summative grade, then you're really dealing with kind of low stakes, and it's not something that has severe consequences. So really the most important for these would be consistency, content, and construct. So just as the final words, assessment should be aligned with instruction. So alignment of the content to the standards is not enough. Make sure that if you want to assess what the students have learned in your course, that you are aligning the assessment with the instruction so that you can measure what you have taught them. Bias should be minimal. Make sure that when you're looking at the design, the administration, how you're scoring, how you're giving feedback, that you're able to maintain a subjective point of view, and that all test takers have an equal opportunity in terms of access to the instruction and in terms of subjective scoring methods. The assessment process should be aligned with what's relevant for the course. It should engage the students in the same types of behaviors that they've been expected to do within the course. If there are any other effects of the assessment, those need to be evaluated also. So any benefit that would affect the students made by decisions that are made using the scores of the exam should outweigh the negative impacts. And if you're dealing with something that's high stakes, you should get evidence from multiple types of stakeholders. So that's it for the validity lecture. In the next lecture, we'll start looking at how statistics can help you interpret student scores and also help you make decisions about instruction. Bye!